Everyone, welcome to another Strace video. So in this one, we're going to get into using Strace to understand what Unicorn and Puma and Rails in general are doing when a request comes in. All right, so let's dive in. Okay, so here we have a 13.2 instance running Puma. And if we just look at PS, see we've got 2 cluster workers, each of which will have 4 worker threads that can each handle a request separately. So we basically have 8 threads total that can take a request concurrently. So let's go ahead and trace a request. All right, so we're going to follow any child processes, get the accurate timestamp, capture the time that each syscall took with capital T. YYY is printing out the file paths. We're capture up to a kilobyte of each string, and here's your output file. Okay, so we'll kick off the trace, and we'll pull up this project that is on local storage. All right, there we go. And so you can see we actually have 3 different requests that came out from the performance bar here. So let's actually look at this. And so here, this is kind of the idle system and no traffic, because this is just a little demo instance with I'm the only user. All right, well, here is the first interesting line. So basically right here, the select. So this process is listening on these 2 addresses, so GitLab.socket and localhost 8080, and seeing which one of those comes back first. Actually, it's listening on 3. Also, this pipe from somewhere. That might be from its parent process. Anyway, so GitLab.socket's going to have any traffic from Workhorse, so external requests. Localhost 8080 will get requests from GitLab shell, so SSH requests that come in, and some GitLab requests as well will fire off internal API calls to make sure that they're allowed to do whatever the request is. Okay, so that's just it's saying either look for external requests or look for internal requests, whichever one comes in first with that select. Okay, so let's just look for where the first request comes in. It's not us. Here we are. Okay, so here's a request coming in on GitLab socket, and yeah, this is get root local storage, which is the path that we put in the browser. Okay, and so here you can see all the headers that are on the HTTP request. Here's our user agent. Here's what we accept. Here's what encoding we accept, and so on. You can see that perf bar enable is even right there. Okay. And then, so it's a total of 16K roughly of data, so we only get the first K of that. So we can't see the full request there. We could use the browser tools if we really cared about that. Okay, so Unicorn and Puma are essentially single-threaded within the context of a given request. That's not entirely true, but it's true enough for our purposes. Okay, so thread 20243, let's just look at that. Yeah, right for it, don't I? Okay, so this is a thread on one of the cluster workers, cluster worker 1. Okay. And if we yeah, okay. So 2, 2, 3. Okay. Yeah, so there's the parent process, which is cluster worker 1 here. Okay. So that's one of the threads, not the lead thread, which is the PID in PS. Okay, and so actually here you can see these get PID calls right here. This is saying, what's the actual process ID here. So this is the actual thing that you see in PS, like we just saw. Okay. In Futex, it's just synchronizing with other threads. So we'll skip over most of this and just get to the interesting parts. So the first thing we do before anything else happens is we write out to production.log that we're starting this request. Clock get time we'll see a lot with Puma and Unicorn. So typically what that means is that something in the background is happening. And so when you see a long string of clock get times, that's just, we're doing some kind of processing in userland, and we just need to know what time it is. So it's really just, we're not accessing the kernel at all other than just get the time. So when you see a lot of those, it's just kind of idle in terms of kernel, not in terms of the actual worker. It's doing something. It's just not, doesn't need to access anything external. Okay, then it reads the status from proc just to make sure its memory is not too high. You get our PID a lot for some reason. Okay, so here we're starting to query the database. This is a local Postgres, so it's over a Unix socket. If it were an external Postgres, it'd be over TCP. It may or may not be encrypted at that point, which would make it hard to read, but conveniently with local, it's not encrypted. So you can see that we're actually sending select to Postgres, and we're getting back something. It doesn't, we haven't actually made a real query there as far as I can tell. So here we go and make our first query. We're selecting namespaces, and we can see all this right here. Select namespaces. Spell. Okay, well, anyway, it's in there somewhere. So we have this long query where we're getting the namespace detail, and then here you can see the response back, which is not quite human readable since most of the data is binary encoded, but you can kind of guess at what it's saying. And it's pretty obvious that we got back a result as opposed to an error or anything like that. Okay, we keep making queries. We're querying on the namespace again, and then we're trying to find the route. So then we join on redirect routes here. We get back some more details. So here you can see all the field names, owner ID, visibility level, membership lock, etc. Okay, now we're querying on projects. And these are all queries that I think are generated by Rails itself. Okay, and I guess we're getting pretty close. No, okay, yeah, all right. So now we've found our route, we found our method. So here we write out to production.log. Here's what we're doing. All right, and so here we're hitting Redis. So you can, when you see these, $, this is a new line with Windows syntax, and then get, and then this is the actual Redis query we're making. GitLab session 2. I can probably see this in performance bar. Session. Maybe not. But yeah, you should be able to see most of those in performance bar. I get a sig pipe for some reason. That's weird. I guess from the parent process. Yeah, 20223 is the parent process. So, yeah, the parent process closed the pipe. Okay. Okay, now we're continuing to query Redis here. We're getting a user key. I guess this is cookie consent. And now we're querying on the user. We're using the root user here, so user ID is 1. Okay. And here we start checking down here for feature flags. Okay, more Redis hits. Actually, we lose our connection to Redis briefly, and then we reconnect. We're getting more details on the user. Are we writing? Yeah, here we are. Okay, we're resetting. Yeah, all right. So now we're writing out to Redis and saying, hey, here are the details of the user. This is all for the session. We get if we need to do a soft email confirmation on this user, because I don't think I ever confirmed the email. All right. And we see if we have an Ldap provider. We don't. Query on the user preferences. Another, I think this is web ID, Monaco. Another feature flag, more feature flags, more feature flags, more feature flags, lots of feature flags. All right, we do not have geo enabled. Okay, now we're back to querying on namespaces. Down here, we're just getting a group back. Okay, and we're seeing if the cache for the project exists. This should show up here, I think. Let's see. Yeah, here we are. Okay. So you can actually see this is the full stack trace for what led to that particular Redis query being made. But we're just seeing if this project has been cached or elements of it have been cached in Redis already. And they should be because I've accessed it before this. Yeah, value T. Okay. Version 0. Is that? That's not a null byte. No. Created at, expires at. Yeah. Okay. All right. All right. So here's what I was saying about these stretches of clock get time. When we see this, this is just kind of checking. It's doing something that we can't see in Strace, right? Because Strace is only showing us what happens when we reach out to the world, and this is all internal processing. So it's got some value back from Redis and some value back from the database, and it's trying to decide what to do next, or maybe rendering. Probably not rendering yet. Okay. More Redis queries. Let's see a theme here. Okay. So now we are hitting Italy just based on this port here, 8075. Yeah, okay. This is the internal IP address, I think, of the server. This should be local storage. For some reason, we're trying to connect over UDP, and it doesn't work because we're not listening at UDP. Okay, so here we're creating a new socket, which is going to be a TCP IPv6 connection. We set some options on the socket, and here we try to connect to that same IP address we saw above for UDP, but with TCP and an IPv6 format. Once again, port 8075, which is how we know this is actually Italy. All right, so we connect, and now we're e-polling here. So we try to connect, and it comes back and says, we're working on it. So here we create an e-poll on that, which is basically saying, I want to be able to wait on this. And once we created that, then we should actually wait at some point. Yeah, it's weird that we keep trying to create this multiple times. We try to make the same e-poll a number of times. It works the first time, and then we keep doing it. Okay. And then eventually we were connected. And now we can, we send a message. So this is an actual GitLab message. Let me bring this up at the top of the page. So you can see that because it's gRPC, we're sending an HTTP2 request, which is, and you can kind of see here is the length of each section of this request. So most of this is in binary and it's not really legible. but some parts of it will be. This particular request, I don't see anything yet that is very easy to read. Okay. Yeah, and we get something back. This is from Gitly again. And it's all binary. I think this is just setting up the connection in the first place. So when I said at the start of the video that Unicorn and Puma are single-threaded, that's where the work is enclosed entirely in a single thread of execution. This is where it actually is not quite true. So you will see the Gitly requests go out on the main thread or process, depending on which Puma or Gitly, but then there are on both of them listener threads that will actually take the response back. So it's not uncommon to see a request go out and then not see a response, and then shortly after you see the server just seem to move on. When you see that, what's actually happening is one of those listener threads has picked up the response. Okay. All right, so here we're getting back an actual response. So you can see this is mostly legible, right? So this looks like Shah, and then here's a message, more messages. Here's the user who created it, their email address, and so forth. And we can see all that in the UI right here. Okay, so that is what it looks like when a Gitly request goes out and comes back. All right, now we go back to Postgres again. Korean namespaces. I think we stopped doing license queries every single time. Okay, oh, here we go. And here is another Gitly request. Let me bring that up to the top. All right, so this is a little bit easier to follow along. So you can see we're calling the get tree entries, Gitly RPC. Here is the bearer token that we send to Gitly to authenticate that we are who we say we are. So basically what we do is we take the current timestamp, Unix timestamp, and then do a hash of that against whatever the secret you set in your GitLab RB is, and that creates a string, and then we add the timestamp at the end to say, and here's the timestamp that I sent, to make it easier for humans to understand what's going on. Okay. Or actually, I guess it also helps make sure it's valid. Either case, here, this looks like the correlation ID here. Session ID, maybe this is correlation ID. Deadline type is regular, so that's going to be 30 seconds, I think. And then here we have the actual path on the hash storage to that project. Here's the name of the project, which we can see. And that should be it. So we send that. Yeah, okay, so here we go. This is what I was talking about. So on 202.243, we send that, and then 10 milliseconds later, we start querying the database without seemingly never getting a response back. But let's see if another thread got it back. Yeah, okay. So 20833 did receive a message back, and it's binary. We can't really understand it. That's just the header, actually. And then down here, we get the full data back. Okay, so yeah, so that's what I was saying. So there's this child thread that's just handling Gitly requests essentially. So let's go back to the main thread now. All right, and you see if we have any project mirrors, which we do not. Notification settings. So things to keep in mind. So basically, when you're looking at this and trying to understand, presumably something has gone wrong, and that's why we're test tracing it. Particularly if it's something that's slow, you want to just look at the timestamps here, and what you're looking for are big jumps. So keep in mind that most syscalls are really fast, and so it doesn't really matter if you see 10,000 lines of a fast syscall run after the other, because that's not a big impact a lot of the times. What we're looking for is one request that took 5 seconds, for example. So that's what you really want to look out for if it's slowness, is just what was actually the slow thing as opposed to how many requests are there, because number of requests and total length of time spent don't correlate very well. Okay, now we're checking project features. We're seeing if we have auto DevOps turned on. I think we do because I didn't turn that off. All right, then we query in license. Some more Redis queries. So things that can commonly cause problems that are not immediately obvious. Slow Ldap sync. So if you're waiting on DNS to get your Ldap server, or the Ldap server is taking a long time to get back to you, you're not going to see that in the logs anywhere. So that's something that Strace is useful for. And you can actually see that we're getting a DNS entry for Ldap. We're calling out to that. It's taking 5 seconds to respond. And that's what makes everything slow. That's one example that's happened somewhat often. Things like database being slow or GitLab being slow, those are usually pretty obvious in the logs that we log those durations in production JSON, API JSON. So it's not going to be hard to understand those, and I wouldn't use strace in general on those unless you're trying to understand something very specific about what we're getting stuck on. And even then, assuming the page is loading, you can use perfbar to really dig into what's taking a long time and where it's coming from. Okay, now we're querying projects again for some reason. And users again. Membership. I haven't wrapped around to the next request, have I? Okay, checking on tags. All right, looking for forks. Namespaces, cache. How many projects we have? Project statistics. Yeah, so as you can see, we query the database a lot. We have 43 queries just for this local storage request, and then we still have 2 other requests that were made. Okay, those are GitLab requests. This time we're getting tree entry, which is, I believe, going to tell us the details of a file. Tree entry. Yeah, okay, so this is probably, yeah, all right, so we're getting readme.md from the look of it. Do we actually see the file name here? Yeah, and here's the file name down here. Okay, now we're doing processing, probably rendering the page there. Yeah, now, so we've taken the result of that first one, and we're going in, getting more tree entries, doing a fair amount of work. Checking for pipelines. Yeah, so I think at this point we collected a lot of the data we need, and so we're starting to do more work to actually render the page in the background. Just based on all these clock get times showing up all of a sudden. Okay. Yeah, let's be rendering here. Okay. Here. All right, and now we're basically done. We've logged that we're done. And this is a little bit slow because we have strace running it, making everything extra slow. I think this is perfbar data that we're sending up to Redis with all the details of each request that we made. Okay, and now we write out the response to GitLab.socket. So first the initial message, and then the full body. Let me mark this spot. Where's the logs at? There we are, okay. Yeah, all right, and down here, we write out to production JSON, the full details of the request. Okay, great. So that is kind of the life cycle of a standard request. You'll see it just come in and we'll query Redis in the database a lot. We'll make a few GitLab queries, and we'll spend some time getting what time it is, and then we'll write out to the logs and to the socket with the response. Yeah, one thing to note is that we do log before we write the response, so it is every now and then possible that we've logged that we're successful, even though the request actually fails. This happens a lot when Workhorse drops the connection. So what will happen is a client makes a connection, goes to Workhorse, Workhorse forwards it on to Unicorn or Puma. Puma starts the work, but then the client drops the connection. Workhorse then drops the connection to GitLab.socket as well. So Unicorn will do all the work, log a 200, or Puma will log a 200, write it out to the socket, and then fail to write it because the socket's already been closed. So in that case, you've got three different response codes being logged there. Nginx will log 499 because the client hung up. Workhorse will log a 502 because the Puma didn't respond in time, and then Puma itself will log a 200 because, as far as it knows, it succeeded until it actually tried to write the response. So that's a little confusing and something that happens fairly often. Just something to be aware of. Okay, so that is, again, the basic life cycle of requests. Let's actually go back up to the start here. Find that. Okay. So with Puma, the process that gets the request in is usually not the one that actually does all the work. Okay, so here we're reading off the socket, but there should be something else. Yeah, okay. Here we are. So right here you can see PID 20246 is accepting. So if we look here, let's do this. Yeah, so we've got 20246 and then 20243. So 20243 did all the work, but 20246 actually took in the request. You can see these are both threads for the same process. So what you basically have is you have one thread that just listens on the socket, and then it accepts the request as it comes in. But it won't. The PID that accepts the request will not be the one that actually does the work. So then you'll see a different PID do a receive from and actually read in the details of the request over the socket. So that's what you're seeing here. 20246 says, actually responds with the initial response, and then 20243 does the actual work and sends back the full response at the end. Okay, let's briefly go over the differences with Unicorn, which are not very great. We'll just go over that same thing we just went over with Unicorn real quick. What is it? Enable or enabled? I can't remember. Enable. Okay. All right. All right, so let's back up. All right, we've got Unicorn now. I don't know if it's actually up yet. Got our two processes. Yeah, let's load the page. Yeah, 502. All right, we'll give Unicorn 30 seconds to come up. I know this is the best part. Just waiting here for this to come up. But we'll be basically done once that comes up. So if you're not interested in Unicorn, then feel free to stop the video. All right, great. It's up. Let's come back. All right, so let's load that. We'll just pull up a file. That's fine. Okay. All right, so the only difference here is that 5628 is the same process that both accepts and actually does all the work. So like you mentioned at the start of the video, Puma has multiple threads per process, and each one of those threads can handle an individual request. Unicorn, each process is kind of an island. You know, it has one main thread within it, which is the work. You know, with the notable exception of the gRPC listen threads. But other than that, you know, it's one process doing all the work with no real threading involved at all. So in this case, you see that, you know, the process gets it, and the process then goes and does the work, and then right now Puma unicorn. And then if we look here, the process ID and MPS actually matches what we see in Strace because it's the main thread within the process that's doing all the work. Okay, so that's the only real difference between Puma and Unicorn. Other than that, all the work you see within the S-trace is going to be the same. Yep, so that is a quick summary of what you can see in a typical Rails request. Great. All right, next time we'll go over Gitlab, which will be interesting. Thanks. Bye.